Okay, so this is chapter 6, and we're looking at section 1, and we're talking about the law of sines. Now, in sections 1 and 2, we're covering two topics that are really closely related, and this topic right here is closely related to something we did in section 4-8. So we were solving triangles in section 4-8, and what that meant was finding all of the sides and finding all of the angles. We're going to be doing the same thing, but we're not talking about right triangles this time. In section 4-8, we talked about right triangles. Now we're talking about what are called oblique triangles, triangles without a right angle. Okay. So the law of sines is a special relationship. Basically, the ratio of side A to sine of angle A is going to be equal to the ratio of side B to sine of angle B and side C to sine of angle C. So we can flip them over and have the angles on top or the sides on bottom or vice versa. But basically we want to solve the triangle, and we want to remember that that means finding all three side lengths and all three angles. And I'm going to have you do something very similar to what I had to do in 4-8, where we'll make boxes. So looking at our first example, if you recall from geometry, this means side, angle, angle. So we have a triangle here. We're going to set up A, B, and C. Angle A is 46 degrees. Angle C is 63 degrees. And side C is 56 inches. Okay, so we're going to set up our box first, and we have angle A, angle B, angle C, and side A, side B, and side C. And angle A is 46, as we already know, and C is 63, and side C is 56. Oops, not degrees, but inches. Okay, and now we're just going to solve for the missing pieces. Well, the easiest thing to find is angle B. So angle B is 180 minus 63 minus 56, and that's going to be 118. I'm sorry, not 118, 71. Okay. And then we can find the missing pieces here. Now, what we're going to do is we're going to solve for the biggest side first, and that's always going to be our plan here. So solving for the biggest side, I want to find side B. So if I set up B over sine of angle B, and I already know this one, so C over sine of angle C, then that would be B over sine of 71 equals C, which is 56, over sine of 63. Now you might be wondering, why did I choose these? What made me decide to do the sides on top instead of the angles? What I always want to do is put my unknown on top. So I knew my unknown was a side. I didn't know side B. And so then the angles would be on bottom since the unknown is on top here. I have to keep it consistent in the other fraction. And again, I'm solving for B because the bigger side is going to be opposite the bigger angle. And I know that I already have this pair set up, side C and angle C. If I had used A and A here, I'd have two unknowns and I wouldn't be able to solve. So that's why we chose what we have here. Now let's go ahead and solve. I can multiply by sine of 71 on both sides, and B is equal to 56 sine of 71 degrees over sine of 63 degrees. When I plugged it in my calculator, I'm going to get 45.2. Oh, I'm sorry. I'm going to get 59.4. Okay. Now this is where a lot of people make a mistake. They think, okay, I have two sides, I can use the Pythagorean theorem and find the third side. But this is not a right triangle, so we can't do that. But I can find that other side using the law of sines again. So A over sine of angle A, which is 46, equals, and I can use either one of these. I'll just keep using the same one. And so A will be 56 times sine of 46 degrees over sine of 63 degrees. And that'll be about 45.2, not degrees. Okay. And that's what we're doing in this section. So there's our first example. I'll go ahead and move on to our next example. Now, in that other one, we were given one side and two angles. Again, here I'm given two angles and a side, but now it's in between. So angle A is 40 degrees, angle C is 22 degrees, and side B is 12 units. Okay. And I can go ahead and fill in what I know. And I can solve for angle B, which is going to be 118. And now I can solve for my missing two pieces. Again, I'm going to go for the bigger one first. So A over sine of 40 equals 12 over sine of 118. And multiplying by sine 40 on both sides, A is going to be about 8.7. Okay. And I can set it the same thing, C over sine of angle C, which is 22, equals 12 over sine of 118. And using my calculator, I can solve, and C is going to be about 5.1. Okay. Now those are the easier examples. These ones we can solve pretty quickly. There's no question about what each missing piece is. But if you recall from geometry, we had angle, side, angle, we had side, 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 we had side, angle, side, all these different triangle, angle, side relationships. But there was one that we said we couldn't use. If you remember from geometry, this one did not work. Okay, so the ambiguous case with the law of sines is where we have two sides and then an angle that's not between them. So for example, here we have a side, and an angle that's not between it. Okay. Now there's four different outcomes that could happen here. We could have a triangle if we're given this piece of information. It's possible that it could be a right triangle. It's possible that given two sides and an angle not between them, that no triangle exists, and it's possible that two triangles exist. In this case, this is this triangle and this triangle that exist. Okay. Now, we're going to go ahead and move on to our next example and see what do we have to do if we're given two sides and an angle that's not between the sides. So here's our first example. It says solve triangle ABC if A equals 43 degrees, B equals 81, or A equals 81 and B equals 62. So let's go ahead and fill that out. We have 43 degrees. We have 43 degrees. Okay. And then A is 81 and B is 62. Okay. And now we're going to solve for our missing pieces. Well, finding these angles isn't as easy as it was before. What we're going to do now is we have our matching pair here. I have to solve for angle B because that's the other piece of information that I have. So now I'm going to put the angle on top, angle B, and side B is 62, and sine of A, which is 43, and side A, which is 81. Sine of B is equal to 62 sine of 43 over 81. So angle B is going to be inverse sine of all of that. And let's go ahead and do that in our calculator. So I have, make sure we're in degrees, we have 62 sine of 43 divided by 81, and inverse sine of that is going to give us 31.5. So that's 31.5 degrees for angle B. Okay. Now this is where we need to be really careful because it's possible that we could have two angle B's. So this number right here, what we're going to do is 180 minus 31.5 gives us 148.5. Now the reason why we have to do this is if you remember, for inverse sine, its domain goes from negative pi over 2 to positive pi over 2. But I get a positive decimal here when I calculate this, and I could get the same angle on this side and still have a triangle. So we need to check and see if this gives us a second triangle. So I have 148.5 plus the angle that we already know, which is 43. And if that's bigger than 180, we have two triangles. Or we don't have two triangles if it's less than 180. So 148.5 plus 43. This is bigger than 180. Therefore, there is no second triangle. If this was less than 180, then there would be a second triangle. Okay, so we always have to check that with the ambiguous case where we have an angle aside, where we have a side, and an angle. Okay, so now we can go ahead and finish the rest of this. We can find angle C, so 180 minus 31.5 minus 43 equals angle C, and that's going to give us 105.5. And then side C we can find using the law of sines as well. C over sine of 105.5 equals, and we can use either one of these. I'm going to go ahead and use A. So 81 over sine of 43. And when we use our calculator, we find that C is equal to 114.4. And then that's it. We have a couple more examples to get through, and I'll go ahead and address those in part 2 of our video.